in lesson 1.1. Now, do notice, fun little calculator symbol, right? Which, by the way, like, you can always take that you can always use that calculator in chemistry. You just have to grab it, you know. So, the traffic pattern of departing flights at Orlando International Airport on a fall afternoon can be modeled by the function v, which is v of t is 92 minus 15 sine of t over 3, where v of t is measured in vehicles and t is measured in minutes. So, okay, easy part to begin with. Find v of t for t equals 18. What are we doing there?
Plugging in 18 for t in the equation.
Right. So when it says find v of t for t equals 18, I would write it as I'm trying to find v of 18.
So it's really, you can just almost just put 6 in the parentheses.
Yeah. So officially it's 92 minus 15 times sine of, I'm going to write 18 over 3, but by all means, does that just become 6? It does. And then keep in mind, calculator, right? So you don't have to worry about, I don't know the sine of 6. You're right, you don't know the sine of 6. Grab the calculator and plug it in. And this is where, yes, your calculators have to be in radians, or it's not, you know, we just assume radians unless they give us degrees. They never give us degrees in calculus. Okay, or maybe never to my memory. How's that? What are we getting here?
96.191 would be vehicles.
96.191. It would technically be vehicles per minute because v of t is measured in vehicles and t is measured in minutes. So, yeah. The other thing now, I just said, you know, 3 decimal places always. In this one, depends on how they ask. You could probably just leave it as this. Okay. Or in other words, it's about 96 vehicles. Okay. B. This is part of the reason I wanted to go over this problem, just because we need to practice with this type of stuff. You know what? You know, that might actually just be vehicles.
Yeah, I don't see why.
Because
per minute. I mean, technically, because it wants it in 18 minutes, doesn't it?
it wants it. Well, it's at 18 minutes is what you're looking at.
Yeah. So,
but now that I think about it, I don't know.
No, it'd just be vehicles.
Yeah, I think it would.
96 vehicles in 18 minutes, basically.
Yeah.
Which would really just be about. No, never mind. I was about to say 12. I was thinking 96.
Yeah. So I think I have that wrong in my answer key. Then is what I'm. So. Okay. B is make a sketch of the graph of time versus number of vehicles. Be sure your graph has a scale. So it does say time versus number of vehicles. So I'm going to have time is always on the bottom axis. It's already labeled T.
So really you could just divide that by 18 if you want to figure out per minute. You don't have to. But
yeah, but that's not what we're asking.
It'd just be easier.
Okay. Now, here's the deal. Do we have to graph this by hand?
No.
No.
Oh.
Because it says it's a calculator active problem, right? So you get to use the calculator. So grab the calculator. Graph that. I should have left.
What the 95 minus 15 sine t or x over 3?
What is going on? Oh, I'm hitting the wrong button.
That's what I'm
trying to.
No, someone messed with this.
Okay. Okay. Let's talk about.
92.
Okay, what interval do we need to be talking about here?
Oh, the window is big.
Okay, so the interval we are officially talking about is 0 to 30, right? So first of all, we have it graphed. I would go into our window, remember this? And I would change my x min to 0, my x max to 30. I would start there.
You can't really see that.
Fair enough. Okay, I don't know, it's being difficult. Even then, it's not usually.
No, I made it worse.
Yeah, you just made it work. I don't. Okay, anyways, it's being really. Now it's got to catch up with. I don't know why it's being. What do I have different than normal? Let me try. Okay, well, we'll go with that. Now, notice we still don't have a graph showing, right? So we have the right x value. Notice my y values only go 10 high, right? Well, what do we know at 18 minutes? What's the answer?
96.
96. So do we probably need to go higher?
Yeah.
Yeah.
I went to 100. You still can't see it very much.
Should be able to see a lot of it at 100.
Most. You just can't see the top part of the waves.
I would say go. Okay, I'm going to change it to 0. 110, I think, maybe. But in all honesty.
Yeah, then
Okay, I just did 0 to 110. That's because I have inside knowledge. Logan, you said you had 100 and you could see what, most of it, but not quite all of it. Now, do I need to really be all the way? I mean, I could change my 0, couldn't I?
Why is mine so much bigger?
So,
Minimum, maximum.
so I could change my y min to, again, I'm going with inside knowledge to save us time. I don't know, let's go 70, would put us in a good ballpark. And now it's a graph you can kind of see, right? So I'm on 0 to 30 and 70 to 110. Is your equation typed in right?
Yeah, I got it. It's just.
Okay. Now, so we know time frame here was specifically 0 to 30. So I know I'm going to set up, obviously, I'm just going to kind of break this. This is going to be a very vague graph, folks. We're not getting very, so I just broke it up into 10, 20, 30. And then what do we have seen happening? Okay, you can kind of do some trace with your calculator if you kind of want to use that as kind of, like if I, not what I wanted to do there, but you can kind of trace, or we can also find like mins and maxes, right?
Mm-hmm.
So at 0, when x is 0, my y value is 92, and I just traced over that. Okay, nothing fancy. Then it looks like what? And you can find the minimum. I'm just trying to shortcut it. Looks like maybe around 5, we have a minimum of 77. So it looks like we need to go as low as 77 and as high as maybe 107. So it'd be like 106.99 type thing. And I don't think, is this one going lower? I think it goes about as low as 77 as well. Yeah, it goes as low as 77 as well. And that's around 23, 24. So those would be, some key points to mark on here because it did say be sure your graph has a scale. I didn't get fancy with this. I just showed that indicating my graph is going to go as low as 77. That 92 is important. That's a starting point, right? And then, what did I say? I was going up to 107. And if I'm just sketching, it's nothing official. I think I said around 5, it was at 77. Somewhere in between 10 and 20, I think it was around 14, 15. You're up at 107.
Yeah, right before 14, or right after 14.
And then, again, sometime later down here, I don't know. Again, it's not very official, but it gets the basic gist of things. Okay.
What do you know?
Now, at 18, it's supposed to be 96. Mine's not exactly on, but is that the idea?
We'll see that.
You know, at 18, it was supposed to come up to be the 96.191. My graph's not exactly, but that's all right. Okay. So that's the idea of what a sketch of a graph of time versus number of vehicles would be. How would we do C? What is the average rate of change of the vehicles at the departing flights over the time interval 15 to 20? Indicate units of measure.
So it'd be like 20 over 15 on the bottom, and then whatever their y values are at the top.
Like 20 minus 15 on the bottom?
Yeah.
Yeah. Okay. Notice it says average rate of change. I'm going to throw at you what I threw at you yesterday. AROC. Okay. So where you can, the y values on top, which, okay, here's the deal. An easy way to write those y values is it's going to be V of 20 minus V of 15. You never actually have to state what the y values are. It's just V of 20 minus 15 over 20 minus 15. Subtracting of the y's over subtracting of the x's. Now, from there, go and put it in your calculator. Keep in mind, we already have that equation plugged in.
Mm-hmm.
Can we use it? Most definitely. For me, it's in my y1. So I'm going to set up a fraction.
This would be vehicles per minute. Okay.
Yes, because it's rate of change. We get it all the same? Okay. So right there, negative 3.999 would officially be, an official answer. Yes, it is about 4 minutes, which in the notes and stuff, we do sometimes say about and say that much, okay, in the word problem scenario. Why is it negative?
It's going down at that time.
Okay, it's decreasing, yes. If you look in the area from 15 to 20, it is decreasing, so it makes sense that that is negative. So I do have an answer written out that the average rate of change is decreasing. Again, decreasing because it's negative at about 4 vehicles per minute.
Yeah, I wouldn't do that because it didn't say I have to.
Writing them out?
Mm-hmm.
Well, here's what I'm going to tell you. You're going to see me write out more than you want to because you have to be able to do it for the AP exam. Okay, so it's that, getting in the process. Okay, D, I don't know if we really need to do D, do we?
What is this exam?
Oh yes, so if you're
May
an
something.
if you're an apes, you get blessed with taking the exam after you get back from senior trip now,
Okay, so that's
because apes exam is the 15th and they're making us leave on the 14th. So we're doing it on the makeup day, which is the 22nd, which is also the day of graduation practice. But they're going to move that till after the exam.
Lovely. D, I'm not sure we really need to do D
No.
because it's instantaneous rate of change. And it's just looking at smaller and smaller intervals. Okay. So, I mean, I can tell you they work out to be negative 4.823, negative 4.803, and negative 4.801. And that would just be from doing like V of 18.1 minus V of 18 over 18.1 minus 18. Repeating the process. Overall, what would you be able to say about it? 18 minutes. Looks like it's approaching the value of negative 4.8, right? Okay. E, why can't the instantaneous rate of change of traffic in the departure lane with respect to time be calculated using the method in part C?
Because
Instantaneous rate of change happens, they want to know the instantaneous rate of change at 18, right?
mm-hmm.
In part C, if you're trying to find it at 18,
the time interval isn't specific enough.
well, what would your time be doing? You'd end up doing f of 18 minus f of 18 over, or it shouldn't be 18, or it shouldn't be f, it should be v.
It would just come out to 0.
Yeah, well,
and you can't divide by
the key is you can't have 0 in the denominator. It's not even about the numerator, but it's about the fact that we'd end up with 0 over 0. Okay, so division by 0 would occur, which is the problem. Okay. Let's take a quick peek at homework.